Good morning. Welcome back to the course. In this lecture, we will discuss green quality function deployment. So, these are the rooms that we have discussed. Next is product design specification. When we think of or when we are going to design a product using quality function deployment, product design specifications need to be known. There are certain specifications that can be considered. With an aim of finishing the house of quality, the product development group ought to likewise be creating the data that will shape the product design specifications. The product design specifications contain every one of the certainties identifying with the item result. It is a list of functions what the item needs to do and is the central control system and fundamental reference hotspot for the whole item improvement movement. So, these are product design characteristics. So, these can be maybe product title or I can just put product purpose. These are things that are stated by product design specifications. The product title, what is the product? Then what market is there? What market would be there? Okay, then why is the need? So, what are the competitors' products or against which kind of product segment is it going to come? Okay, these are the things which should be stated by product design specifications. Certain product design specifications can be classified in these ways: general, performance, constraints, general or purpose of the product, target cost to a customer, need for the product, benefits to the user, time for the product to reach the customer, customers size, weight, quantity, competition, service life, market evaluation, trademark, performances, functions, features, constraints, can be shipped, disposed, manufacturing. What I need to make the point here is that in the constraints we can think of energy consumption as one of the constraints. Also we can think of the environment, though they are talking about the factory environment, we can think of the environment. Also we can think of the end user requirement. Then recyclability. Materials and components, is it recyclable, is it disposable, is it available, or the suppliers recyclability. Then shelf life. So, these are the things that we can consider. So, product design specifications that we can consider for green products, and QFD can also be applied to services and the systems. So, I will put products or systems. Okay. QFD is generally run in phases. The first what we have seen, we had the words from the customer: taste, cost, appearance. We had the technical requirements, or not exactly technical, we had the quality requirements, weight, size. But can manufacturer use these requirements to actually build? Can he decide what kind of heating process he would use to bake the biscuits? What kind of material would he use? In every example what we had the customer voice, or the voice of the customer. The customer voice was translated into design characteristics. Now these design characteristics using the house of quality phase 1 are got, and they become the input for the second phase. This is second phase. The second phase is, the first phase was house of quality, the second phase is product design phase, in which design specifications become the input and the product or service characteristics are developed. So, these go to the phase 3, this goes to phase 3 to get the processes which are need to be used to actually manufacture. This is process design. Next we have the processes and the control. How can we control the process? At least these three phases are there. So, process control, if not developed or established, at least the processes which are there are to be mentioned. So, that is there for the same example. You can go to this website also to see the details in this example. This was the customer requirement and functional requirement, those were related. This functional requirement, now these are the kind of design specifications which makes our input for the second phase. This is phase 2. Okay, this was phase 1. This phase 2 is something where we get all these design details, baking time, okay, engineering specifications, you can say baking temperature, order of ingredients, length of wet ingredients, mixing time. Now, we get these values. You might be noticing a few highlighted values here. These are the values 1 and red color and 1. These are values 1 and 1. What are these values? The weight in row 4 is not being addressed. It is red. It is not even present here. No relationship found. Right? So, weight is not even being addressed. These values 1 and 1, row 3 and row 5, these values 1 means they are not being substantially addressed, because they are not having a great contribution towards our analysis here. Similarly, in the previous matrix, this weight was 1. This is also not significantly addressed, because we can see their maximum relationship value is too low. It is 1 and 1, and the maximum value is 1 only. So, these are not being addressed. Next phase we have the phase 3, where we get the parts and materials, the oven type, the baker experience, flour type, vanilla type, shortening or the butter that we need to put, egg grade, container, chocolate, ingredient or shelving. So, this is the third phase in quality function deployment or house of quality. This is the way we get to translate the voice of customers to the manufacturing specifications in 3 or 4 steps. So, this is quality function deployment. Now, how can we devise green quality function deployment or green house of quality? Green quality function deployment, this is a study done by Dong et al., and you can go to this link to read the whole paper. This is a research paper which was done in 2003. They said there are certain phases to establish the green QFD. They call it GQFD3. The first phase is the general phase, in which we get the voice of customer to the technical requirements. These are done through these HOQs, house of qualities. First HOQ, then the second HOQ would come. Okay, then the third word would come. Right. So, these will give us the technical requirements. Those are gotten from these. All these illustrations are adapted from this research only, Dong et al. So, this is the QFD that we conduct. So, voice of the customer is the input and we get the technical requirement. So, this is the technical requirement or identification or identifying technical requirements. This is phase 1 in GQFD, green quality function deployment. Next is phase 2. In phase 2 what we do, we have two houses, we get to make greenhouse and cost house. Okay, this is the greenhouse that we make. And a cost house is made. These two houses, when they are taken together, I am putting a plus sign here, they give us the environmental and cost data. Okay, input is from this side and from this side. This is phase 2. And cost data establishment. Right? Now, what is this environmental data? In environmental data, we have here life cycle assessment and life cycle costing. Life cycle costing, as I said, it is the purchasing cost plus operation cost minus salvage cost. The total life cycle, the total cost that is spent on the product for the whole life cycle. You purchase a bike, the cost of the bike is rupees 50,000. You use the bike for 10 years, in 10,000 you have spent the price on the fuel and the maintenance. Let me say that price is around 1 lakh and you have sold the bike at rupees 10,000. So, that will be 50,000 the purchasing cost plus 1 lakh, that is 1.5 lakhs minus 10,000. 1.4 lakhs is the life cycle cost. So, we can compare certain products in the similar range using life cycle costing. Life cycle assessment is when we have inventory analysis, impact analysis and improvement analysis. I will tell you, this is inventory analysis, then impact of the product to the environment. Then can we improve it? Improvement analysis. Okay, these are certain stages. I will discuss life cycle analysis in very detail in the coming sessions which I will take next. Life cycle cost is the purchasing cost plus operation cost minus salvage. So, these are the inputs in greenhouse. Cost house is a general cost house that we have seen the cost of the product that we can just estimate or we from the past data. There are certain ways to estimate the cost, there are certain ways to do the cost analysis. There is a different tangent. Cost analysis is simple, we are no more concerned about the greenhouse here. Both greenhouse and cost house make the input in phase 2. Next phase here is, now in life cycle assessment, this approach considers all the material and energy transfers which are involved in raw material extraction, processing and manufacture, including cradle to grave of a product, while life cycle costing is a methodology used by designers in conjunction with life cycle assessment. It takes into account the costs involved in handling, processing, using and so forth and salvage in all the life cycle stages of the product. So, these two are the inputs to the houses and we get the environmental and cost data. Next comes the third phase. Phase 3 is product concepts and comparison phase. What happens? We get the the performance data or the quality data, the environment data, and the cost data. These are now given as input to the concept comparison matrix. Which akin to another house again, right. So, there are certain product concepts I can put here, product concepts, different concepts for the products are there, and using these data, these different kinds of data, this goes as input to our concept comparison. So, we get the phase 3 in this way, that is product concepts comparison. So, what essentially is in this phase? In phase 3, the concept comparison matrix is established. This matrix is established. In this matrix, all the product options under consideration are documented with their quality, cost, and environmental attributes. These data are derived from the house of quality, the greenhouse, the cost house that we had in the previous phase. These data are developed from here. Those data are given as input here. The choice for the best product option is made in this phase. We get the best product here. So, this is the final output in this phase, right. Next is the product or process design phase. We just need to select the best product based upon the green criteria, because we have greenhouse here, we have cost house here. This greenhouse is now bringing in the ecological factors or the sustainability factors here. So, the product that we have got here is now a greener product. Product or choice. If we are comparing one or two products, this is a greener choice that we have taken, and also the cost and performance is taken into consideration. Next, phase 4 is the general QFD phase. We again have the 4 phases of QFD with us. 1, 2, 3, and 4. So, this is design, process planning, then we have production planning, then we have retirement planning, because we are also considering the green factors. Retirement planning is the part of the green QFD. Green QFD is end of use or after use. If you remember, you have 3 phases: before use, during use, after use. All these phases we also see how we can put there. So, that the government planning is the part of the QFD. Green QFD here is a process planning. So, this is design deployment. So, these goes as input in here, second one, these goes as an input here, and these goes as an input here. So, phase 4, that is the product and process design phase, in this QFD techniques are utilized to develop an optimized manufacturing process for the product concept that is chosen in phase 3. The product is chosen here, okay, this product is taken to phase 4, and finally we have this production planning and retirement planning. These two are the development in the phase 4. So, phase 4, let me put it in a clear way, phase 4 is our product or process design phase. This Dong et al. Has conducted a study in comparing the coffee makers. They have developed these data, quality data, environmental data and cost data. So, this is a house, we can say this as a complete house, quality as a complete house, environment as a complete house, or you can say these are rooms in one house. So, this specific first house is comparing the quality data. Quality means performance, as we say, performance or functions that we said, right. So, this is high temperature retention by the coffee maker is one of the functions, lightweight is another function, non-messy operation is the third function, ease of operation or lightweight and high temperature retention. So, they developed this and they established this rating. These ratings give us the total quality input. Let me differentiate these. This is our environmental data, this is the quality data, the third one is cost data. Now, these are developed using the similar way that we have seen in our previous slides. So, they conducted this study and developed these ratings for the quality or the performance of the product, and the final quality points are obtained 111. This 111 is 10, this 10 into 3 plus 9 into 4 plus 9 into 5. These are the points, quality points. From the quality viewpoint, they observed that the coffee maker 1 is the leader, maximum points. And in the life cycle stages, this is manufacture, use and dispose. If you remember, manufacture is before use, this is during use, this is disposal is after use. This is the same pattern that we have seen in the previous study that we conducted on value engineering, before use, during use and after use. So, they identified the carbon footprint or the ecological or the points that they gain. Here more point means more environment friendly product, means lesser pollution, lesser wastage. So, the maximum here is again for the coffee maker 1, but the cost for coffee maker 1 is quite high. Okay. In the terms of cost, the minimum cost is for coffee maker 3 and coffee maker 2 is in between. So, these 3 rooms are developed in this concept comparison house. After a detailed technical analysis of each product option, a design team is required to indicate the extent to which each product would satisfy each of the customer requirements. This is done using numbers in range from maybe 1 to 10. A high number indicates a better degree of achievement. So, those quality data are developed here in the quality room. Then the total quality points for each coffee maker is calculated, as I said, by multiplying the importance ratings for each customer requirement by the corresponding quality points here. Now, environmental data room documents the eco indicator. This is the eco indicator. These are the eco indicator values which are associated with each life cycle stage of the product option. Then these values are obtained from greenhouse, which is established for each coffee maker, and those are put here. The cost data room documents the life cycle cost of the product. Next, we have a decision tree, decision hierarchy. Best product has to be gotten from coffee maker 1, 2 and 3. We have the quality points, eco indicators and cost data, right. In order to compare the products in terms of their environmental, quality and cost attributes, pair wise comparison was carried out for each of the products. The contents of the content comparison matrix, this content comparison matrix was used for this purpose, and the pair wise comparison was carried out using these ratings. So they actually conducted AHP, that is an analytical hierarchy process. Need not to go into this detail, but you can read about AHP. We will definitely provide you the notes or the links to read this. So these are the performance ratings in 9 levels. We had only 3 levels in our numerical comparison study, but they had 9 levels, in which the first level is equally preferred and the 9th level is extremely preferred. In between, the 5th one is strongly preferred, 5th one is strongly preferred here. So these ratings were used to get the numerical comparison. So the comparison between product design is done using a scale from 1 to 9 here. For comparing coffee makers in terms of quality attributes, the quality points documented in quality room, these points were used. And for environmental and cost comparison, green room and cost data. For environmental and cost comparison, this environmental and cost room data were used. Then they developed these comparison. This is for quality, this is for environment and this is for cost. Please do not get confused with this chart here. This is another way to see the numerical comparison that we did. This is 1, 1, 1 means no difference. Coffee maker 1 cannot be compared with coffee maker 1. This is the importance rating. This 2.25 means if one coffee maker 1 and coffee maker 2 are compared and coffee maker 1 is 4 is moderately to strongly preferred over coffee maker 2. Coffee maker 1 is preferred over coffee maker 2. That means coffee maker 2 is 1 by 4. This is actually 1 by 4. This is 4, this is 1 by 4. This is 6. In the opposite, we have 1 by 6. If this is again 4, this is 1 by 4. Okay. So these gives us these quality priorities. These are in quality priorities. We can see the coffee maker 2 is moderately to strongly preferred to coffee maker 3, again 4. So the diagonal elements are always 1 and the remaining values are reciprocal values. This is 1 by 4, 1 by 6, 1 by 4, reciprocal values depending on the previous assignments that we have made. The priorities are found after normalization to the table values. This is normalization of the data. Normalization is the, we take sum of the values, these are sum. For the very first chart the sum is given, for these the sum is not given, this is sum. Okay, this priority is, these values are obtained, 0.6711 is obtained, such as 1 by 1.42, this is actually 1 by 1.42 plus 4 by 5.25 plus 6 by 11. Oh, this is the priority for coffee maker 1. Similarly, we can get priorities for coffee maker 2 and 3 in the terms of quality. We can get the priorities of coffee maker 1, 2 and 3 in the terms of environment, then for cost. Now these 3 priorities are gotten. Now these 3 become the criteria as in value engineering. These become the criteria: quality, environment and cost. Now these 3 are compared here. The quality, environment and cost are compared. When these are compared, it was seen that the environmental and quality requirements are given an equal preference. Quality and environment are given an equal preference, 1 here and similarly 1 here. The environmental requirements are given a moderately higher preference over cost requirements, and the quality requirements are given higher preference over cost requirements. Quality over cost is higher and this is moderately higher. So, we got the weights for these values for quality, environment and cost. In this case, the environment is given the maximum weight, you can see here. Based upon these weights, we get the score for the coffee maker, and finally coffee maker 2 wins the battle in the terms of quality, environment and cost. This is a study, you can read the details in this research paper. We have given the link here, and it is conducted by Don et al. In 2003. You can see this is an open access which is available. This is green quality function deployment. I would request you to do a task. Let us recapitulate before. We saw how could we describe the voice of the customer. We saw what is quality function deployment, what is house of quality, how is it used as a technique in quality function deployment, what are different rooms or elements in house of quality, how can we get product design specifications, okay, or what are product design specifications. Then 4 phases in QFD. Then we discussed green QFD. So, this is what you have seen in this lecture. The task for you people is, like we have seen QFD for biscuit. So, I would like to request you to pick a product, or you have already identified the product in value engineering study. You can pick the same product, that is, let me say the product is chair. Okay. I would request you to do the similar kind of analysis as we have seen in this green concept comparison house. This was coffee maker 1, coffee maker 2 and coffee maker 3. In place of these, you can put different materials for chair. Chair made of metal, made of wood, made of plastic. Then you can get the quality room, environment room and cost room. It is up to you, the product that you select here. You select quality, environment and cost. In quality, you can put here the functions such as durability, okay, then weight. Pick the attributes. You can see some attributes, what are the different specifications of a chair. In environment, before use, during use and after use, these attributes can be put. In cost, you can determine or estimate the cost of these elements, or even you can conduct the QFD. If you want to do a detailed task, you can conduct a different phases of QFD, and you have to find some information available on the internet or in various journals or various periodicals on the specific product that you have chosen. So, this is the task for today. With this, green quality function deployment chapter is over, and we will meet in the next lecture where we will discuss design for experiments and life cycle assessment. Also, we will work on certain online and offline software tools while assessing the life cycle, while conducting the life cycle assessment. Let us meet in the next lecture. Thank you.